Okie dokie. It's time. Doing the vibe stuff today just to learn a little bit more. Didn't have any time yesterday because I had D&D. But need to get back on the grind because there's no reason to assume that. Well, I don't know about that, but there's no reason to assume that. Oh, fuck, never mind. It's a waste of words. It's a waste of words. All right, let's go. Ordered some sunflower seeds too because I like them. Needed some sort of treat that lasts a while. So meaning that when you declare a local variable, it's default initialized, but a global is value 0 initialized. Oh, excuse me. Even when you're only declaring it. Cool. Jesus. Allergies are back again already. Great. Excuse me. Excuse me, get Costco variables, yeah. Need input and output. Do It's known at compile time. Oh. What? Who said that? I guess I did a weird hotkey. It was like 6 or 7 or 8 or... I don't even know. I don't know what I pressed to do that. Hey. Once I finish learn CPP, I need to learn different things, like different IDEs or Vim or other things. I don't really understand Vim. I think it's like a maybe a pure command line interface IDE. That way, when I eventually apply jobs, the odds that everything I code is going to be in VS Code, or rather Visual Studio, 0. Hmm. It's annoying because then you have to explicitly call them, and if you want to change what the variable gets, then you have to add parameters. Then you have to find every call to it. Then you have to add the arguments. Then you have to remove the global variable from the function. Like, come on. Hmm. Excuse me. Don't know what Bursley means, but I'm going to put a global variable within a namespace, within a user-defined namespace in this header file, and then I'm going to include it and then do stuff with it. Yep. Okay. So, from a namespace, find in a header file, we are accessing a global variable, or rather, we're printing a global variable, a global const expression variable. Oops. Oh. Located within a user-defined namespace. It's a global variable, global const expression variable. Let's note at compile time, value is 0. But then, we have another header file with a function in it. in that function, I'm gonna test some stuff real quick. Yeah. The file that function is defined in needs access to the same stuff. Well, it's best. I can include IOStream here. This would print anything I want, but I want this itself to have this file itself in this function to have access straight to this global constant expression variable. So it needs to see the namespace in order to actually get that variable. And it needs IOStream, but that's already in the same one as that variable. Oops. Excuse me. Oh, you also need to include. So it seems like we need to include a declaration to the namespace in order to see what's actually in it. So that's why we need Bursley in here. We also need work H in order to see do thing. So that's why we have it forward declared there. So we need work.h. Yeah. Cool. That gets the point. I could format it to make it be ordered the same way. I just wanted to try that. Oops. I just wanted to not say, or to put a global variable in a namespace in one file, have a function that'll access and print it in another file, and also do it from main, showing that you can do it from. Oh, what is going on here? Huh? Uh-oh. Guess it's gone. Shit. Dang. Okay. Yo. Yo. Where's my C++ file? What the fuck? Damn, I guess I accidentally had the main one selected. GG's. It's gone. Yeah, nothing. Oh. Am I stupid? Guess so. Okay. Yo, where's my shit at? Okay, I'm gonna create another project just to see what's up. What if I do this? I don't know. Why is it opening Unreal? Oh god. So there's one. I didn't add it to the right spot. I don't know if I need these files. Cool. I did not. Must have been what I named my first header file stupidly. Cool. Okay. See what happens if we do. Oh. That's the fastest way, actually. By just going boom and then up. And then we'll do. And we'll have a. Haven't used them yet, though. Oops. Can't use him because he hasn't been initialized. Cool. He's instead just const. Still hasn't been initialized. Ooh, const object must be initialized. Excuse me. Oh. Yeah, because he's given a shitty value at the start, so it requires you to actually give him a real value. Okay. Yeah, because the global variables are in scope. Inside inner blocks. But so it's a local variable. So if we had x as a global variable and a name, well, if it was in a namespace, that'd be easy peasy, because then it wouldn't be hiding it because we'd be accessing it using the scope resolution operator. But if it was simply named x and it was in global scope without being in a user-defined namespace, then if we had x in a local variable or in a local in a function, attempting to do stuff with x would do stuff to that x, not the global x. And it doesn't even have to be global. So we just have oops. Yep. Yep. Uh-huh. Mm-hmm. Yeah, because if you refer to an identifier, well, at least if you refer to a variable, then a block, it will refer that identifier, subsequently refer to that variable within the block, and no longer refer to the same identifier for variable outside the block. Or meaning above the block at a higher level, outside of it. Within meaning deeper into blocks, and out meaning closer to global scope. Mm-hmm. Yep. Yep. Mm-hmm. Yeah, just like we could have a couple of different things. We could have okay. So we could have like so first we don't have any held items, but then like, oh, okay, we're assigning it 5, and then we're gonna output it. So we need to include IO stream to get input and output, the I stream and output stream and input stream types. I see issue because we're hiding it here. But these are two distinct variables. Created here. And value initialized. Outputting outside variable. Outside inner block, or outer block variable. Local variable. Oh, sorry, this isn't a local variable. Yes, it is. It's within a function. These are both local variables. that, but we get warnings as errors because that's how I have it. No hiding. That way it's always evident what we're printing. Just in case I forget that something's already defined and I define it later on, like, oh, player health, and then we say player health is yeah, like if I'll do it real quick. Couple things. Get input and output. So we can have int player health here, and we'll just say it's 100, that's max health. And then we'll output it. I need to get better at the commenting. I'm gonna need input and output. $100 outer block player health, and then we'll say we're just gonna output player health. Outputs outer block player health. Nope. Okay. Oh, and I forget that we could do the spaces before and after the block. No, it's easier to see than this. So type mom text away. Okay. Love getting a text from mom. It's good. Probably call her tomorrow. It's good. I'm not trying to pester everybody all the time. Gotta have some shit to talk about. And then we'll do. Oh, the player got hurt. In player health is max health. Let's say make a header file and call it player stats. And then we'll say, this is sunflower seeds. I'm not eating. I'm fine talking while chewing. I can't talk while chewing, but I can talk while eating. So I'm gonna stop being so damn quiet. We need to say if not defined already, player stats h, then define player stats h, and then end if, so we can so exactly what we're only including if it hasn't already been included once, which should be everything. And it will say namespace player player stats, and then we'll say int player int max health. Max health is here, and then we'll include player stats. Oh, we got hurt by the fucking skeleton. Let's say int skeleton damage, and we'll just say it's 10. This minus skeleton damage. Cool. And then we need to and this is into block player health. And then we're gonna output it. And then, oh, forgot to show my mom something. Excuse me. Nice. Let me find something real quick. Bro, where are the shorts at? There we go.
Lower your standard of living, you entitled just like everyone else. Are you f***ing stupid? What are you talking? Lower your
Cool. Okay, doke. Oops. So we're gonna get warning as errors, but the point here is this. Oh, okay. This is my player's health. I'm gonna output it. Okay. And then the player gets hurt, and then forgot that I already defined the health somewhere else, because maybe, let's say I don't already have, or maybe I just didn't mean to put player health here. And this in the correct, well, let's see. In reality, player health should have been here, or it should have been somewhere else that I was updating by, I'm full health, but I just got hurt, so I'm outputting it. The point here is that seems like it could be easy to accidentally identify or define the same variable twice, and I won't get any issues. Nobody will say anything if they're in two different blocks because they're within two different scopes, so it's okay. But we have warnings as errors enabled, which says, hey, if you have an inner block that has the same identifier of something as an outer block, an inner block with the variable whose identifier is the same as an outer block, well, you won't be able to access that outer block unless it's like in namespace stuff, and we just say player health, and we'll just say it's 120. Then this is cool. Well, wouldn't matter because it's not defined here, but we'd have stuff player health, and then we're not initializing it now. Stuff player health. Stuff player health. Oh, hold on. Oops. Cool. Now we're good because this guy's within a namespace, so these two are distinct. Player health here does not hide this player health here, so we could also output stuff player health. Oh. And then we can actually output this without worrying about the shadowing. And this, it would actually make more sense if we do this. This. Bump. So we have 120 at 90, but we can still get the 120 because we can still access this guy because we're not shadowing him. And we don't need player stats anymore. Oh. Oh. And then just showing that we can change the value of outer block variables from inner block variables. We need input and output. So we'll do, yeah, sure. Int player health, 100. Player health is now 99. Player health. Show updated player health. Player health. Show updated player health from outer block. From inner block. Update player health. List shows and declare, define, and list initialize player health. Oh, oops. Okay. And then we would have it here. This guy's created here, he's updated here, he's outputted to show the update here, he's there, we're cool. Alright. I want to actually run that though. %, keyboard, can't hold an arrow key, woo! Nor can I do control arrow key. Cool. Outer block, update, okay, cool. post update. So I guess we can update outer block variables from inner blocks. Cool. Mm-hmm. Oh, yeah. Same thing. Yeah. So we just do input and output for debug purposes and to test. Or not debug, but testing purposes, visualizing purposes. We're just gonna say that there's this poorly named global variable, and we'll just call it sure, player health. We'll say it's actually a constant expression. Constant expression, int player health, and it's 100. Then we'll say int player health, and we'll say it's 200, and then we'll say, oops, player health. Cool. So the point here is we're saying compile time known const expression player health. It's a shitty comment, but known at compile time global variable should be named better, like G player health, something like that. And then we'll say local variable will shadow the global variable due to overlapping name. Oh, don't need to. It's just obvious. Cool. Hides global declaration. Shadowing, sounds like. So we can have block. Local variable. Hides him. Global variable. Block. Local variable. Hides him. Oops. Him. Hides him. Cool. True. So we could do show. Oh, actually, we don't even need that. Oops. Oh, because it's maybe the use? Maybe not. Yeah, it's still the declaration that's hiding it. Sure, we can use it in a specific way to use it, but we're still going to get warning, error from warning. Yeah, so we have value. Oh yeah, true. Did we learn this? Never used these yet. Haven't done any incrementing action. We try that. Let me see what's happening. Local variable define. Prefix incrementing. That happens before. We're saying add the value, kill the guy, and then evaluate. And we're outputting. So it should be outputting 8. And then we're going to go here. And then we're going to output. We're not passing him anything. So we just call him. And he outputs value. So he's going to output this value. He's not shadowed here. Because the only one that is in scope here is this one anyway. So it's only going to refer to that. And here, this one hides it. So we can't access this guy in here. So we do value here. Then in main we have value. Hides the global variable. Increments the local variable. Not the global variable. Yeah, because it prioritizes the one that's within the box. And then we prefix decrement him. But we're prefix decrementing this guy. So we're probably going to print 8 and 4. Yes. Problem though is the hiding of the variable is where I get the compiler error. So if we did, I don't even need to output. We'll just do. So if we did int player health, excuse me, and then we'll just say player health. And we're doing that, and then we're gonna do, oops. Cool. And then we'll have int player health. We'll say it's 200. Yeah, sure, we could say, technically, player health. And then we'll put them in parentheses. And then we're decrementing, or we'll just say incrementing him. Problem though, is there's still a shadowing happening. Yep. Makes sense. Yep. Oh, so I could choose. Yeah, Visual Studio has warnings enabled. Yeah, and I have I wish it mentioned in here. That was close. Almost spit the seed out on myself, my shirt. What are other people saying? Outer block contains a non-shadowed reference to the shadow variable. You can still access the non-shadowed reference. Oh. So if we have a variable that has the reference, then yeah, that's later. We're still not doing it. True. Let's try that then. So we'd have global variable named int player int book pages, and there are 10. And we'll say print pages. And then we'll just say there's a void print pages, and it takes int called book pages, and outputs book pages in this book pages. Oh, still, those are both functions. So, a local variable defined with the same identifier as the global variable, and maybe the same type too. What if we said void, or sorry, bool, and we just say one. It's one page. Same thing. So it's the identifier is the point. Okay. So solution here is I should do need input and output. We'll say const expression int book global book pages 10, and then int book and then int book pages 15 book pages Cool. Yep, so we can access both. No shadowing issue. We're cool. G for global, baby. Houston, we are G for global. I think we discussed scope versus linkage. Linkage being whether or not two identifiers refer to the same object, versus scope just being where an identifier can be used, where it's known. Cool. Yeah. Seems like the only ones that can violate the ODR. I don't remember the ODR, but I remember part of it being that only inline variables, functions, and then types, and then templates can be redefined in different files, or can be like in the same scope, I think. Sounds like internal linkage here. Or like local variables, is global variables. Alright, what happens if we have I'll just say that. Then we'll have a header file. We'll just call it big. Oops, if not defined, big H, define big H, and diff to stop including the rest of the shit, or to stop, or to allow other shit to be included multiple times. This defines what we're only able to include at one time within a given file, within a given program, I guess. We're talking transitive here. Because if this has already been included in one file, and that file gets included in something, this is included in that final one, because this is just when you include something, it's just copying the code over. Which is why we only do 4 declarations to make the compiler happy and see a function. We don't actually include the definition, because then we'd get a multi-definition or redefinition and compiler error. Due to probably internal linkage? No. Due to ODR. Multiple definitions in the same file. Fuck, it's in a namespace. Can we do X? Sounds like we can do that. Oh, int X. Cool here. Oh. Now we get an issue. So it's in the same scope. That's the problem. So, one translation unit. And a translation unit, is that the whole program after being translated? Or is that one initial file, or one individual file? I don't remember. Sounds like it's source files. So if any source file trying to understand this stuff. So local variables have no linkage. Oh, and those have oh, I see. Because a local variable only exists in its own function, and is completely distinct from any local variable in another function. We got function X, we got function do thing, we got function do stuff. Both of them have X. They are independent. There's no linking. It doesn't matter. Same file, same translation unit, 2 of the same identifier. Still no issue. Doesn't refer to the same object. There are sometimes where they can refer to the same object. So there's no way for 2 local variables to refer to the same object unless there are reference to the same object. Like if I say X and I create X, where X is, and even if we did 2 references, this is a reference, this is a reference, well, those are just individual buckets that are in 2 separate spots that have the same information or that are looking at the same thing. They're still independent. There's no linkage. So two local variables, two different things. That's it. But global variables, just like we saw there, we were using the global variable after including him in one source file, and he was already existing in another source file. They were redefining him. So some sort of linkaging going on here. Seen and used in a single one, but is not accessible from others. Okay. I don't know if I've seen any variables with linkage like this, with internal linkage. Two source files. Oh, hold on. Global variables and function identifiers have either internal or external. So if we have a global variable and we have them in one, and a global variable in another. Oh, let's test that. I only did it with a header file. But if we do a CPP file, that's an implementation. Doesn't need to be included. Can't be included. Maybe it can? I don't know. We'll do, we'll just say test. What happens if I include test? Oh, it doesn't even work. Maybe you can only include header files. Makes sense. We already have int x here. He's default initialized. We have x here. It's the same one. It's in two separate files. Seems like there's external linkage here. Or sorry. Yeah, external, because they're not referring to different objects. They're not independent. They're actually dependent. They refer to the same thing. That's why it's giving us a multiple issue here. So we're talking about linkage now, not compiler errors. Doesn't seem like I've had this before, unless we're talking about namespaces. Different namespaces. Excuse me. Oh! That'll do it. They have external linkage by default. So the translator sees file X. File X. Compiles cool, compiles cool. Okay, time to link. Oh. There's an issue. These two are referring to the same object, motherfucker. They don't have internal linkage. If we make them static, static, we're cool. Maybe. Because they're independent. Int x, int x. But static, static. Only in this file, only in this file. Wonder if that prevents you from accessing it with a namespace somewhere else. I don't know. Let me check something real quick. May not be visible to the linker at all because it says, yo, don't link him. Just like local variables. Probably not visible. sounds like this is what static is doing. Visible is by default external linkage, but now we're giving them internal linkage. So it seems like a translation unit is the binary translated version of source code. Internal variable. Oh. Well, next section or 2 sections from now is why non-const global variables are evil. Probably because they exponentially increase the name conflict chance. I guess not. If we're talking about always using the G underscore, but maybe. But if not, they will. Let me check on Della real quick. Fuck, man. Okay. Oh. Oh, they're called internal variables. Okay. I was waiting to finally get tired of sunflower seeds. It took a minute. Holy shit. I like chips more, obviously, but all the chips have all the bullshit in them. I love Takis so much. They're my favorite chip. Doesn't even come. Oh, fuck it. It's not that it doesn't come close. It's just that the Trader Joe ones are so damn expensive. I need to figure out if I can get them like wholesale shipped here or something. Because if I can, I'll buy them. Sure, they could be friggin' fried and better stuff. And they're pretty good. They don't have all the dye bullshit in them, so I'll take it. Because that stuff is not good for the heart. Be right back. Please? Please. Alright. Okay. So if we have... I need to sit right again. I need to do the meta. This. I'm gonna get a little bit of music on and see if I can stay so damn as clear-headed as I am. Yuck. Let's see. What am I doing, bro? We're doing... Oh, Ojo. Ojo... Tonight, I think is what it's called. Yeah. Cool. Turn it down, make sure I don't get destroyed. We need a function. Oops. We need too loud. What do I need? What do I need? Oh, yes. So we're gonna say we're just gonna do X just to be just to do the most name conflicty it could be. We're just having an int X, and he's default initialized by whatever the hell the compiler wants to give him, 457, who knows. And then we're using him so that we don't get a warning error for not using him. And then we're gonna have another C++ file, and we're just gonna call him test. And we're gonna say specifically what it is. I need to get better at even my temporary naming schemes. We're gonna call this linkage test. And we're gonna say int x. Issue. It's only used in here. Well, it's used here and here. Cool. Compiles. Cool. Compiles. Problem? These two conflict. There's two flat things, no conflictions. But it's like this. I remember when we used to do this in elementary school. It was weird how you can make your fingers go limp like that. But it was weirding me out why they're so dang. Like if I do this, it's fine, and they're not like that. But if we like really crease them down hard, it's weird. You just like lose control of the tips of your fingers. They're just limp. Like I don't. It's insane. I don't have any control over that. I can't control this little nub. I can do this. I can flex this to control that part, but I can only control. It's like there's a string, there's a thread that goes here, and I can, and somehow I can move it like this, but I can control this, and I can control that, but I can't I can like kind of, but if I do this, if I fully contract, it can't go any further. So this is just like a useless little thing. It could just be whatever. Doesn't matter. But valid, compiles, but issue. These guys are global variables. Default, they have external linkage, meaning they're referring to the same thing, which means if I just do this here, type specifier. Oh, because technically this guy doesn't know about him or hold on, type specifier. It doesn't know about him at first if we just do this. But then when I actually specify the type, then there's a confliction. So it needs a type, but it also can't have a confliction. Otherwise, linking error. So that's why we get a compiler error if we just do this. It doesn't have a type. But when we give it a type, now it conflicts by the linker. So it's compiling properly now. At first it wasn't, because it wasn't valid. But now that they're both valid, there's a linking error. Why? This guy isn't static. Oh, now he's alone. This guy isn't const. Now he's alone. This guy isn't a const expression. And it could be value initialized, because value initialized is just 0. It's known at compile time, so it works. Please, what are you doing? Cool. So, give global variables, turn global variables internal, or convert global, make global variables internal. Thing. I was hoping I had italics, but no. Internal. Using, for what? Static, or static const, or const expression. Cool. This girl's voice is fucking crazy. A lot of skill. You know, I'm glad I didn't start coding till now, because otherwise I wouldn't have such a damn passion for gaming. And it would have been boring to just be learning. I mean, sure, I could have made cool stuff, but I wouldn't be making what I want. Like the end goal, if I had just started, if someone put a computer in front of me and started giving me like fucking Scratch or whatever, C++, and I was figuring shit out from age like 8 on when I started playing video games instead of video games, dude, I wouldn't have this desire to make my VR game and to revolutionize the VR industry by implementing different sensory stuff by collaborating with researchers and whatnot. Like, oh fuck, there's like a perfume company that's doing this. There's OVR, but there's yeah, no, there's a bunch of these like little shitty ones that are just like little samplers. I mean, they're not shitty, but I mean, they're shitty. They're not what we want. They're just like a box, and it puts shit out, and it interacts with oh, I entered this room, and then the thing smells, but it's not inherently the right. Damn, she's got some gummage right there, bud. But it's not inherently in the right direction or anything. It's just shit, man. What you need is the motherfucker, boom, on you with the capsules here, and then a mixer, and then send it up, and then mix it. But only mix just enough. That way, if you enter a cave and you need to do that sulfury scent, but then you leave the cave, you don't have to vent all the sulfury shit in waste. Instead, you just make just enough. So it'll be a hard design to make, but I'll figure this shit out. Cause I need my VR. I need to go home, put this thing on, and then lock in, and I'm good to go. Oh wait, this can actually be comfortable if it's actually not even bad if the headset isn't too big. What about this? That's kind of bad. I see black dudes do this a lot. I don't know why it's comfortable though. Like, I mean, I guess it's just rappers. It's not. No, but well, maybe if the head is wide enough, it's probably. It's usually fat dudes, I guess, who do that, and they have wider heads. So this automatically works, but this headset, even at the smallest version, is still too big, so it doesn't have enough tension and it doesn't lock in enough, and it's too narrow, so it doesn't get like my ears are pushing it off. I got big ass ears. So yeah, static or make him const or make him a const expression. Okay. But then I'm gonna have to include him to actually use him somewhere, or just have him in a namespace. But then I still have to include him to get that namespace. I'll just fucking maybe unused shit. Yep. Oh yeah, true. You do maybe unused in front of your constants and stuff. Yeah, I mean you only have to type it in once and then you can use it later. Maybe or maybe not without the errors. So. Huh. Storage class specifier. So the way that it is stored, which are rules that govern how the linker. Yes, sets the names linkage and storage duration. Okay, makes sense. So maybe it's to store it at a certain time, or maybe, and then says how the linkage works. Okay. Static extern mutable. It's too cold. Oh. Oh. Man. I think the other side of this needs some of that back support. Hmm. So it can be. Mm-hmm. Oh. That makes sense. Yeah, because so for external linkage, we can't have multiple definitions because they're referring to the same object, which means we would have a redefinition. So for it to be used in a const expression, it must be seen by the compiler. The compiler must see the definition, not just a for declaration. But we can't have a definition. We can't have a a redefinition. So instead, by making these const objects internal, we can put them in a header file and include that header file in multiple places. And because those different files that are included in the same, let's see, hold on. So it's one definition. Well, no. It's a definition here, but we're copying that code into multiple things, so we're defining it in multiple places. That way, each file that uses it in a const expression has its own definition, and that's cool because it has internal linkage. If it had external linkage, then the compiler then the linker would bitch at us for redefining it in multiple locations. So if we had gravity, we had like this physics library in this header file, and we had gravity in there, 9.8, whatever the fuck, 9.82 meters a second squared. And we include him into multiple spots, and there are const expressions that are using some sort of formulas to calculate things by definition. Like maybe there's a tower file, and the tower file, or there's a ball file, and it's about a ball's fucking acceleration downwards in this one context with wind, and then there's another one with a different wind value, and another file with another wind value. Each of these are const expressions, and those values need to be known at compile time, which means that the values of all the shit in them need to be known at compile time, which means that gravity needs to be defined in each. Well, if gravity is an external linkage variable, so it's a global variable that's not const, a const expression, or static, well, it can't be defined 3 times because it has external linkage. The linker's going to bitch at us. The compiler will be happy. It'll be like, yeah, I see the definition. Cool, const expression. Cool, cool, cool. Cool, 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 cool. First cool being, I see him. He has a definition. Cool. Known at compile time, you can be used in a const expression. Here's the value. Good. But then the linker fucking bitches because of the external linkage. But by making it internal linkage, cool. Excuse me, if we want it to be changeable, we can do static. But if we want it to be unchangeable, then we do const or const expression. Cool. Const expression being fully 100% known at compile time and calculated at compile time. Compared to const, where it's maybe, maybe not, depending on the different rules in the compiler. So now we can use that physics library with an internal linkage variable, gravity, and then I can use them in const expressions in multiple files because of internal linkage, so the linker doesn't bitch at us, because the compiler bitches because of syntax and definitions and shit, but the linker bitches because of seeing things too many times when it's putting all the pieces together. It's like, hey, this file has a little missing hole, or this file has, this file's full, this file's full, this file's full. Well, if I try and put, it doesn't make any sense. Okay, cool, I understand. Nice. So, didn't finish it all because I accidentally pressed spacebar. Yep. Internal linkage can have a definition in each translation unit. Yes, exactly. This allows const to be placed in a header file and included into as many as needed without violating ODR. Yes. Each one has a definition. It can be used in a const expression. Yes, exactly. Exactly. Egg Zachary? Egg scrambled Zachary? Inline variables, who the fuck knows what those are? I don't know. Which can have external linkage without causing ODR violations. Really? Oh wait, yeah, because it said internal variables, internal function, or sorry, inline variables, inline functions, templates, and then types, meaning templates, types, and then internal variables, internal functions. Those apparently can be redefined in the same program. Whereas externally linked guys, KO. I was thinking about a global variable that's within a namespace, if that would cause any linkaging errors. but it wouldn't because it's already in the same scope. So I think maybe it's fine, right? We have main, we have X, then we have another file, this header file. We have a namespace, we have X in there. That one is the namespace and then the scope resolution operator in the next. Versus this one is different X. So it's technically a different scope, it seems like, right? We do. But maybe it's also a case where we're still going to get bitstat. So we'll see. We need a function. We're just going to say we're going to use X. And then we're going to have, an int named X. And he's just going to be default initialized. And then we're going to have another file. And he's just going to be called, namespace linkage test. And he's going to be int X. He's going to be namespace linkage test. He's X, int X. Well, what? I didn't type X. I'm stupid. Cool. Oh, so the issue is. Oh, wait, hold on. Yeah, because he's in his own scope. But if we had like this. So it's a scoping thing. So we only care about that when they're in the same scope. If they're in the same scope in two different files and they have internal linkage, then it's okay. Because we could have a function here, main, so that we can run a program. Okay, this typing mode sucks. I like having my wrist on the table. I'm trying to find. Oh, that's kind of good. Like putting my elbows on these armrests. How is this shit getting dirty already? Oh, that's pretty good. And then we'll just say whatever. We're using X. Well, actually, we could say instead of just using it like that, I should probably get better at doing maybe unused int X. And then we'll just value initialize them. And then we'll say there's another one. It's a header file. And it is called namespace linkage. Namespace linkage. And we have int X. We have a linking issue. Because they're within the same scope. They're both within global scope. Versus if we make a namespace linkage test. We'll just go to the end, put him within like that. Oops, I forgot. That's not how we do that. This. Now we're cool because it's within this different scope. Okay, so linkage is only an issue if we're talking about the same scope. So we're talking about internal linkage here. So we're talking about global. We use it in a thing, but not. But it still has external linkage by default. It's just that we're not using it in the same we're not redefining it in the same scope like that. I understand enough. Then we have inline variables later. Okay, cool. All right. Functions also have linkage. Okay. Oh yeah, so probably the same thing. So we could have a function. Oh, maybe unused function. Really? Would we even care about that if we had like int main and then we had void do thing? Yeah, it doesn't give a shit. Oh, but the problem is the return value, I think. If we have int do thing return. What even happens if I do that? No, yeah, because it's saying that that's the name. So, but if we have a type, and then we have int x, we just default initialize and then return x. Yeah. On. Ah, damn. Alright, what if we say value initialize them? Alright, it's cool. So, oh, what about that? If we have parameters instead, so if we have what? But oh, so what if we did that? Wait, no, you still don't care. We're still not using them. Yeah, doesn't matter. They default to external, but can be set to internal via the static. So if we have for declaration to it. Oh, I wonder how that would work. If we had a for declaration. Oops. Oh, this is just trash. And we had add. What if we just do do thing, and then we'll have a header file called thing. If not defined already, define thing h and if, and then we'll say we'll do thing, and then we need a C++ file. Oh. Okay. And then we'll have an implementation file. Oops. Implementation file called thing. Okay. Say thing will include thing. That makes sense. Cool. All right, so if we do this just for the return type. Say void do thing. Oh, the point was I'm gonna do static. And I think this means the type is gonna be different from this. We have an issue here. Oh, static. Non-standard type, or what did it say? So if we said this, and then we say we need to include thing so that we can use it. What in the fuck? Okay. But then we say static. Oh. Declared but not defined. So if we say we're using him like this, he is external linkage, meaning that these files refer to the same thing. He's declared here. This is valid. Cool. But he needs to be defined if we're using him. Are we using him? Oh, we're using him. Okay. So now we're cool because we have the definition or the declaration here. But now we need the definition. Okay, cool. These guys are referring to the same thing. Oh, wait, hold on. It's not being redefined. Actually, I need to check that a couple times. So the whole point here is we're including this guy here. If we, well, we don't need the return type when we're calling it. So if I stay static, uh-oh. What is he talking about? Oh, that's funny. So if we're saying declared but not defined, is declared, but the compiler is not able to say this thing is not able to tie this to this. He's used here, he's declared, but we don't know what he is yet. So it's preventing it from being known. It's declared but not defined. It's an unreferenced function, even though it is referenced, but it's static. So it's actually not referenced because it's a different function, because this is a different type. This is a qualifier. Unreferenced function with internal linkage, because it has internal linkage has been removed. And it's been removed on compile time because he hasn't been used. Excuse me. What the hell's happened? My phone's blown up. Cool. So we can set it, and it prevents the linker from saying called here, defined here. Nope. You got to be defined in the same one, buddy. It won't link. Yeah, it's exactly it here. We're using him here. We have forward declared him. Cool. We've called him. Cool. Where's the definition? Oh, compiler won't see it because static. It's in a different file. Seems like if you're using him in one file, then you might want to do that to prevent. If you think you're gonna do one with a similar name, then make him static. So like maybe you have them for different classes or different class files or something, and you want to avoid name conflicts with other ones because all the shit's gonna be included and whatnot. You might make them static. Like if you have a movement function for one type of thing and a movement function for another, and those are distinct because maybe it's like a slug's movement, and the way to figure out a slug's movement, and it's like stuff is totally different from a character's walking and whatnot. Maybe it's just maybe one uses like root motion and it's an animation where it's like every animation that's played, that's all that's happening, so it has to call an animation, versus another is literally just shifting the character forward, maybe for the slug. Maybe it's like shifting it but then rotating it like that. Well, if you have the functions called movement, let's just say it's void and void movement, and then void movement, and then you include them both in similar shit. Well, I don't know if you would, but let's say you do. Well, you're gonna have an issue if they're both external, buddy. So you may as well make them both static. Seems like that might make sense. Won't link because add is not accessible outside of add.cpp because it is static. Static makes it stuck to its own file. So it seems like a translation unit is an individually compiled file. One file that's been compiled and is ready to be linked up. The one definition rule says an object or function can't have more than one definition. Other than that, okay. Internal objects that are defined in different files are considered to be independent entities. Yeah, so we can have movement in one, movement in another. Uh-oh, that's a problem. That's in the same program. Uh-oh. Oh, but they're static, so it's okay because internal linkage. They're independent entities. Even if their names and types are identical, so there's no violation of the... Oh, ODR. Why do you call it the on definition rule now, and then before you were calling it ODR? Motherfucker, dude. Be right back. Be right back. Okie dokus. Ready to go. So, yes, we have one definition rule. They're independent entities, so we're not violating the ODR, even though we're having two functions that are not inline functions, unless a static function or an internally linked, or a function with internal linkage is an inline? I don't think so. I don't think I know what inline is yet. So, they're independent. We don't violate ODR. Are we close to the end? Oh, we're at the end. Nice. Static versus unnamed namespaces. The use of static. Oh, using static versus using namespace. Unnamed namespace? I still don't even know what that is, motherfucker. Use of static is falling out of favor. Unnamed namespaces can give internal linkage to a wider range of identifiers. Gotcha. Yeah, but... type identifiers? Yeah, but isn't a type... a type? I don't know. They're better suited to giving many identifiers. Okay, so when we're using static, is it only functions? No. You can also do static there. Okay, but we can also do unnamed namespaces and inline namespaces, whatever the fuck that means. So an inline namespace with variables in it, it's probably an inline variable. Makes sense. Why bother giving identifiers internal linkage? Yeah, motherfucker, so we can avoid name conflicts potentially? Maybe? Maybe? Well, let's see. Why bother giving extra... We don't have a quiz? Damn. Oof. Yep. Yeah, it's true. Yeah, so hmm. Oh, that makes sense because we call one function and that function calls another function that we don't want other things to call, so we make the helper function static or the one that does all the extra shit. Like if we say print values, in print values, one has to fucking create the values by calling another function. Maybe the create values function needs to be static. Maybe there's another function or another function and another function that are all part of the print function and pass values back for the print function to return. So like print function would call a function that returns values to the print function which returns those values to it. Or rather the print function may just return and then call a function that has a return type. Maybe those functions are all static because those don't need to be called by anything else. I don't know if it's better for efficiency per se, but assuming that they're not within a namespace, let's just say they're global functions. I don't know why you would do that, but let's just say they're global functions. Well, I guess you could call them in multiple spots, maybe. Yeah, I guess so. But if you don't want them called by other places, you make them static. But you could also make them static to avoid naming collisions as well. So you could have like maybe there's a global variable in another. So there's two files in global scope in both. There are two add functions, and maybe one adds these two types of things. One adds these two types of things. Like one is a vector addition. One is an integer or a float addition, something like that. Well, we want to use add for both. Maybe we only want the vector addition to be called by this one certain thing, so we make this guy static. That way we can still use add and not conflict with this add, and we can still use him in a bunch of files, and then we can call things that use this guy, or we can call him, well actually no, we can't even call him directly in other files. So we call things that use this guy, make him static. And making static also, instead of a namespace, if we wanted to, but namespace maybe is the way to go, static would also prevent these guys from conflicting. So it's for naming collisions. Because identifiers with aren't supposed to link it. Motherfucker, he's. Oh, yeah, yeah. Oh, wait. What? Hold on. Motherfucker, you said maybe. Or not. The point is that they're not used by the linker. That's the point, really. So, I mean, they could be known by the linker, but they're not used by it. So they aren't exposed. I guess that's what we could say. Maybe. Maybe. I don't know about. I don't know. I don't know if I agree with that word. Yeah, that's the cool part. Well, and just to not be able to call them privatized functions. Giving every variable and function that isn't meant to be used from another file internal linkage. If this discipline, it's a good recommendation. Oh shit. Static const expression? Holy shit. And that got me kind of excited for a second. Learning. A lighter touch approach as a minimum. As a minimum. give it to any identifier that you have an explicit reason to disallow access from other files. Okay. It seems like that might be the strat, just because automatically making them static, then you have to go back and make them not static. But if you only call the ones that you need, it seems like that's less of an issue. Give identifiers internal linkage when you have an explicit reason to disallow them. Consider giving all ones you don't want accessible. Well, yeah. So the whole point is give everyone that isn't meant to be used by another one and won't be. That's the tough part. So isn't and won't be, and isn't and shouldn't, and shouldn't in the future. Internal linkage. And ones where you want to specifically wait, same shit. Consider giving all identifiers you want. Oh, okay. So you just put them in an unnamed namespace instead of doing static for all. That probably makes sense. Many modern development guides, let me reread this. Recommend giving every variable and function that isn't meant to be used by another internal linkage. It's good. So, probably won't be used by others, give them internal linkage. Ones that definitely shouldn't be used, like those helping functions, definitely internal linkage. And you have an explicit reason, consider doing it using an unnamed namespace, which we learn later. Internal global variables, so we have static boys. So there's non-initialized, but he's default initialized because he's a global variable. And then initialized. Oh, I gotta poop. Oh no. Constant. That guy has internal linkage due to const. Same thing with const expression. Those are already initialized. Those are also used by const expressions. And then we have a static function that is a global function, but is internal, so it can't be used by other files. Even if the motherfucker's included. Because why? We can only include the for declaration. So this guy can't be used by other files. Oh, okay. Uh-oh, please? What happened? Okay, I gotta go to the bathroom bad. Oops, that's not right.